Friends, today's NRI Samay program from Los Angeles brought to you commercial free by listeners like you. Your generous donations make possible for us to stay commercial free, and today's show is pre-recorded. If you have a question for the guest, please send an email to nrisamay@gmail.com. We will follow up with the guest and find the answer for you. Thank you for your support.
Friends, welcome back to NRI Samay. This is your host, Sri Hari Atluri. We will be discussing about El Nino weather pattern, which is expected to create a lot of rainfall or snow in California region. So we want to talk about that and also greater damage or something that we should be aware of. To talk about this, we have Svetla Hristova-Veleva. I'm sure I did not say it right. She is the scientist at JPL currently. She's an expert in atmospheric sciences, but we want to listen more from her. Svetla, welcome to NRI Samay. Apologies if I mess up your last name.
Oh, not at all, Sri. Thank you very much, and thank you for inviting me to your show. It's a pleasure.
Excellent. Thank you very much again. You did most of your studies at Bulgaria, then you did master's and PhD in Texas A&M, right?
Yeah, that's correct.
Okay. Could you tell us what you are currently working on?
Yeah, my expertise in atmospheric sciences and more particular in the dynamics of precipitating systems and storms. So what I've been working on for the past 10 years maybe, it is on developing tools to observe precipitation from satellites and to retrieve the rain, also to analyze the weather patterns, but also to simulate using the state-of-the-art numerical weather prediction models to simulate storms so that we can then evaluate comparing to observations, how well the models do. And this gives us clues for how we could improve models. Also, we use these kind of simulations in the design of new instruments because we can simulate how the instruments would look like before they are launched in space. So what I want to point is that my expertise is more on the dynamics of meso-scale convective systems. These are smaller systems, not climate type phenomena, but just precipitating systems that are the building blocks that eventually form our weather and climate. I've been working at JPL for a number of years, but I also want to point that all views that I will share with you and to your listeners are actually representative of my own understanding. And as a scientist, I do not speak on behalf of JPL. And I think that's a brief summary.
Okay, excellent. That's fair enough. But for common people like me, some of the things you mentioned, we don't understand fully. So maybe at a higher level, just correct me if I'm wrong. I think you're working on, contributing towards building tools or instruments which are used in satellites, and which in turn they could study or predict, storms or weather patterns and things like that, right?
Yeah, exactly. So the modeling part of my studies are exactly toward helping others toward developing new instruments. And then we use the observations from these instruments, past and current, to understand what the weather looks like around the world.
Excellent, great. That's awesome. A lot of, especially nowadays with movies like Gravity, Martian, I think there's a lot of enthusiasm about space and space shuttles. So this is a really special area that you are working on. A lot of kids probably want to grow up and become scientists in, our scientists are travel space and stuff like that.
Yeah. Yeah, thank you. Yeah, I think this is really exciting time, and you're absolutely right that the interest is spiking. Actually, the JPL Open House was a week ago, and there were so many people who wanted to visit JPL. It was virtually impossible to have everybody who wanted to come on the premises, but I think future events will help with that. But in any case, yes, I think the interest is growing, and this is very stimulating for me and for my colleagues to see that the public is interested in what we are doing.
Yeah. So let's talk a little bit about the El Nino. What does it mean, first of all? Is it like, so it's not another like a monsoon or another just a storm, one of the storms, right? So this, I guess, this happens once in a while. Is that right?
Yes, you're absolutely right. So the meaning of the word actually means the child, the child boy or the boy child in Latin, and it comes from the fact that this phenomenon, which, as you said, is occurring at some intervals, but not absolutely regularly, and we still don't understand exactly what determines the intervals. But in any case, it's most pronounced when it happens. It is most pronounced during the winter time, the months of December and later on. And because of that, it got the name from the Christian religion, the child, Jesus Christ, because it comes around the time of Christmas.
Wow. Okay. Well, I did not know that. Yeah.
Yeah, but what it is, I wanted to describe a little bit broader. So, as we all know, the sun, because of the shape of the earth, the sun rays do not come straight at all different locations, but the sun is most perpendicularly shining around the equator. And around the poles, the sunlight comes into a steep angle. And so this creates a big contrast in temperature between the pole and the equator, and the equator is hot and the pole is cold. So naturally the atmosphere tries to redistribute the heat and move the heat from the equator toward the pole. But because the earth is spinning, this air cannot go all the way to the pole, and eventually it turns toward the east, depending in which direction it is going. But at upper levels, it turns toward the east, while at low levels, the air is trying to go toward the equator, and so it turns toward the west. So normally the winds that blow around the equator are the so-called trade winds, and they blow from east to west. So that's the normal situation. So what these winds do is that they basically, when they blow over the ocean, they push the surface water toward the west, and the surface water is warm. So these winds normally push the warm surface water from, let's say, if we look at the Pacific, they push it from the Americas toward the western so-called warm pool, where it passes. And the waters in the west are, the warm pool is deep, while on the eastern side of the Pacific, near the Americas, it's this upper layer of warm water is very shallow. And as the water is being pushed toward the west, it has to be replaced by something. So this creates the so-called upwelling, meaning that the colder waters from below are pulled up toward the surface. And that's why, if you look on a map, you will see that near the Americas, the west coast of North and South America, the ocean temperatures are cold. And that's actually why we have this climate here in California, for the same reason. So this is the normal state of affairs. However, every once in a while, something happens in the Western Pacific, and so a wave is generated, which starts to move toward the east. But what it really happens is that these winds that are normally just blowing toward the west now become weaker, or sometimes become even blowing into another direction, toward the east now, in completely reverse direction. So what this does is that it allows this warm water that has been piling in the Western Pacific to kind of flush back and come toward the Eastern Pacific. And when this comes, this is actually the El Nino event. So it basically is manifested by the fact that now we have warm water that is in the Central Pacific and even the Eastern Pacific, not only on the surface but deep below. And so basically this is the warming event we call El Nino. So what happens in the atmosphere when El Nino happens is that the convection which feeds on this warm water, and its most normal state is in the Western Pacific, so it starts moving toward the east as well, and it comes to the Central Pacific and to the Eastern Pacific. And we saw this summer already the manifestation of the El Nino with the many hurricanes that happened in the East Pacific, which were pretty unusual in terms of their strength and number. And what I wanted to say is how is this affecting us? So as the convection moves toward the Eastern Pacific,
So just to understand, so in general, it is warmer on the western side of the Pacific, so the water is moving towards the west. So the water below, under, on the east side, which is closer to California, is coming from bottom to up, and that's why it's cold, right? Now you said on El Nino year it's the opposite. Is that right?
Right.
Yeah, so the warmer
water
is actually on the eastern side. And why is, I think you explained, but why is that different on El Nino year again?
Right, because it is a number of events that come together, and it's the atmosphere and the ocean that play together, and basically convection starts to happen, intense convection maybe in the Western Pacific, which creates this so-called westerly wind burst. It draws air and it creates a wave in the atmosphere that starts to propagate toward the Eastern Pacific. But it's basically due to intense convective events, the winds could reverse their direction or just simply weaken. They don't blow as strong toward the east. So basically, if you think that the winds are piling this warm water toward the Western Pacific, when they weaken, this water washes back toward the Eastern Pacific.
I see. And how often does it happen?
So that's the question, because we don't know all the components and how they play together. But it has a cycle on the order of 7 years, but it doesn't mean that it will be happening regularly every 7 years. As you have seen recently, it has been a prolonged period of time during which we did not have an El Nino event. Last year, it was forecasted to be an El Nino event, right, and it began to show signs, but then it disappeared. But this year, it seems like it's holding, and it's all been. So the scientists have developed different indicators to monitor the state of the El Nino, and all of them show that it is among one of the strongest so far. Basically, they monitor the temperature in different regions in the Pacific and other indices, and combine all of that to determine the state of the El Nino.
I see. So no particular, we cannot guarantee. It's about 7-8 years, but it is no guarantee, right?
Yes, there is no guarantee. There was the famous El Nino of 1982, and then another one in 1997-98, which were really strong, but there were others in between. So, but whether it's going to be a very strong one or a mild one, as I said, there are many factors that come to play together, and forecasting this is quite difficult.
I see. It just reminds me of like a glacier activity, or not a glacier activity, geyser activity in Yellowstone. Once in every 70 minutes or so, it just comes out. But I guess this is a lot more complex and too many factors influencing when it happens.
Yes, because it's also important when these burst events, intense convection in the West Pacific, when is it going to happen? And so, if there is a seasonal cycle in the structure of the ocean as well. So, as I said, many things have to come together at the right time, not the same time, but the right time.
Exactly. Okay. You were telling about what can we expect or how this is going to impact.
Yes, So, as I said, convection moves with the warm waters because it is fed. This is the fuel for the convection. So, as the El Nino progresses and the temperatures warm in the Eastern Pacific, with that comes the convective events. They move also toward the Central and Eastern Pacific. And what convection does, these clouds that are sometimes ordinary, small, and sometimes organized in bigger systems, they pull the moisture from the ocean. The winds evaporate vapor from the ocean, and the convection pulls this moisture up in the air. And so now we have more water vapor in the atmosphere in the Central and Eastern Pacific. And this water vapor then can affect us, as we saw even just 2 days ago, this big flooding event in California was related to tropical moisture. It was not created there was a pressure system, there was a dynamical situation that helped, but a lot of the moisture was generated as a result of the warm sea surface temperatures in the Central and Eastern Pacific. So why El Nino becomes more pronounced in terms of effects in California during the winter time is because during the winter time there are also these cold frontal systems that normally come through from the north, and they kind of organize the moisture that is now sitting in the equatorial region, the Pacific. They organize it into something that scientists have started to call atmospheric rivers. Because if you look on a map of the distribution of moisture, you will see them really like rivers. They're narrow, but they have a particular direction, and the moisture flows this way. And so when a river like that hits the continent, then it starts to rise because it's dynamically forced. And so as it rises, it cools and generates precipitations. And that's why these atmospheric rivers are of great interest right now, and they're being studied by many people to understand what exactly their structure is and how they form. But they are thought to be contributing to the majority of the precipitation, especially in our regions. In a couple of years ago, this event was known, of course, but it was known under the name of Pineapple Express. I don't know if you've heard about that before.
I heard that.
Yeah. So that's why in wintertime we have more atmospheric rivers, and especially in an El Nino year, they'll be hitting the southern portions of the U.S. So where they're going to hit depends again when the cold systems start to come, where exactly they will be and how they'll be collecting the moisture. So there is uncertainty. And also, the great question for us is, if it's going to hit in the mountains toward, let's say, San Francisco, and in the Sierras, most of the precipitation will hopefully be in snow, and this would be much more beneficial to us. If the precipitation comes as rain, it's not going to be as beneficial because a lot of it gets back to the ocean as a runoff. So we will not see the great beneficial impact of the El Nino. And then it also rain creates mudslides, as we just saw what happened on Interstate 5. So hopefully it will come in the mountains in terms of snow. That would be much more beneficial.
And I hear different numbers, but what are the chances that, this might even happen or not? I heard like 40%, 60%, different numbers.
You mean That the El Nino will happen?
Yeah.
Oh, so at JPL there is a scientist who is our resident climatologist, and you probably have heard his name, Bill Patzer. So I spoke with him recently, and he said that, I'll quote him, that this is too big to fail.
Oh.
So, yeah, so it's pretty certain that it will continue through the winter. I mean, it is here now. We know for sure it is here. The question is how long it will continue. But the indications are that it will continue, and his prediction was for twice as much rain as normal, twice as much precipitation as normal.
Okay. So, well, normal, I don't know what normal is, but last year it was pretty bad. So,
yeah, well, no. Sorry, go ahead.
The normal as we have seen in last 3-4 years, or normal, before that?
No, for a longer term normal. We've been in drought for the last several years, severe drought. So, no, we're not talking compared to last year, but compared to averages that are different around the state, and I don't know the numbers, but not really, not just the last couple of years.
Okay.
It's a longer term climatological average.
So you are saying this will be rain probably, most of the water might go into ocean, but I think overall the precipitation is good anyway, but also there can be damages, right, to like mudslides and stuff like that.
Yes, that's the big problem and concern, that it as you saw how it came, it comes in big storms, and it's kind of stationary, so that's prone to create mudslides and lots of damages. So, yeah, I think we should be prepared for a lot of events similar to the one that just happened 2 days ago in the region of I-5, north of Los Angeles. But if it comes as snow, then, as I said, it will be much better. Let's hope for that. Yeah.
Okay, great. And you said, let's see. So this is kind of a warming effect. So it's going to be, I guess, a little warmer this winter.
Yeah. So it has. It's mostly going to be wetter. The sea surface temperature is warmer, but it's in the winter time, so we would not see.
Yeah.
What's happening this year, which is also, I think, unusual, is that not only the El Nino is forming as it usually does from the events that we have seen in the past, but right now the waters of California, which are not part of the El Nino, we are further up north. But even these waters are much warmer, and they've been warmer for the last couple of months. We've noticed this during the summer, that the water was much warmer than we are usually used to it. So it's a combination. So now we have two warming effects. But what we are going to see, it's mostly the wet. It will be raining a lot. And I think the last big El Nino was 97, 98. So
I see.
Yeah, if you remember that one, I do remember. That was the time I moved to California, and it was raining in June and July, and that was not what I expected.
Yeah, no, I was in India at that time, so I didn't even pay attention to news in California.
Friends, NRI Samay is a non-profit independent alternate media from Los Angeles, USA, which brings positive stories from grassroots activists from all corners of India and across the world. NRI Samay does not rely on corporate funding, and our shows are commercial free. We only rely on your donations. Corporate funded media is driven by the TRP rating, and profits are blurring the distinction between news and entertainment. Why do our news channels talk so much about cricket, movies, accidents, popular figures' personal lives, babies of heroines, gossips, etc., while they should be covering the struggles of people, inequality in our society, rural issues, and border security issues? Why did our media raise some corruption crusaders to the sky on one day and shut them off completely when graft charges were raised on those corporate sponsors? Media relies so much on the corporate funding and government blessings that they cannot report independently. NRI Samay is different. We don't accept funds from any corporations and hence our shows are commercial free. We completely rely on donations from you. Please consider donating to NRI Samay and please go to NRISamay.com and donate generously. This is the only way together that we can continue NRI Samay. All donations are kept transparent on NRISamay.com. And if you have any questions, please write to nrisamay@gmail.com.
So the El Nino, this is is it just a weather pattern, or do you think it has a relationship with the global warming, or or is it too early to say anything about it?
That's a very interesting question. So El Nino is a large-scale phenomenon, and it affects the weather around the world. So when El Nino comes, we have wetter winter season here. But at the same time, there is dry season in Australia because this water now it's not there, it's here. And so the El Nino itself modifies the jet stream. The jet stream is in the mid-latitudes that determines the weather in the extratropics. So the El Nino has impact on the structure of the jet stream, and this is how its effect around the world is propagated. So it's really a significant large-scale phenomenon. It's not just the weather pattern around our region. How it is related to climate, it's an interesting question. I'm not sure I can tell the whole story, not at all. But there is a relationship. So basically, during El Nino, as we said, we have, let me talk briefly about the opposite effect called La Nina, which means the girl, the girl child. But it's just called in this way because it is unusually cold waters near the eastern Pacific, unusually cold waters just on the west coast of the States and the South America. And so these two events, when they alternate, they change the whole, as I said, the whole circulation. And during La Nina events, which is the cold phase, we see expansion of the tropical region. The dry regions in our part of the world expand kind of polewards, and during El Nino they shrink. But talking about climate, so we've all know about the rising temperatures, and they have been rising with a pretty steep rate for the last 20 years, except maybe I would say the 20 years at the end of the last century. So right around the beginning of this century, so about the year 2000, it seemed that the rise of the temperature suddenly slowed down significantly. And so scientists refer to that as the climate warming hiatus, basically. There is no warming. The trend seemed to have stopped. So this created a lot of questions. People try to understand what the reason behind that could be, because the models weren't predicting that. They were predicting continuation of the rising. Yeah. And so people considered different possibilities. One of them is the solar activity, because solar activity has an 11-year cycle, and at that time it was at the low period of the cycle, and now it's in the high, but even so, it's not a strong event. So that's one possibility. Then scientists consider the contribution of aerosols, because, pollution in the air. As we throw more particles in the air, they block the sunlight, decrease the amount of sunlight that comes. Yeah, so they consider this event too. But most recently they found that both of them do not explain what we have seen in the last 10 years. Instead, it's the ocean. So it turns out that during the last 10 years, the oceans were warming deep below. So heat has been stored in the oceans, and so we did not see this heat. It kind of was disappearing. And this is during the cold La Nina event. But during an El Nino event, all this heat will probably be released again to the atmosphere. So basically the expectation is that the temperatures will rise.
I see. So it's just a temporary thing, I guess, right? That temperatures did not rise?
I'm sorry?
So just,
sorry.
I guess temporarily they did not rise, but you are saying below the ocean it's still warming.
Yeah, exactly. It seems like the heat was stored in the ocean and it's going to come back. That's the expectation. On the other hand, more recent results seem to indicate that actually this was misleading, that the temperatures continued to rise, but the way we account for them showed us that they weren't rising. In any case, the expectation is that during an El Nino event there will be a reflection and there will be rise of temperatures, surface temperature.
And at a broader level, scientists in your community or even across the world, when we talk about the climate change, what are the areas that they are working on most? What is the hot research topic currently?
Yeah, well, okay, these are big questions too. But, with the melting of the ice sheets, the sea level is rising. So that's a big concern to many areas because there is a big population that is living in low-lying coastal areas, and they could be affected very strongly. In addition, the winds contribute to uneven sea level rise. So we see some regions that experience stronger sea level rise than others, and that depends on the atmospheric circulation. Also, higher sea level increases the potential for damages by storm surges from hurricanes, something like what we saw with Hurricane Sandy, when Hurricane Sandy hit New Jersey, and it was not a strong hurricane at all, but it was large, huge, and it lived for a long time, so it piled a lot of water and it just brought it with itself on shore. So if the sea level is rising and we have powerful storms, the flooding potential is increasing. So that's definitely one big problem. Another one for areas where we live is actually the drying. And I want to make the point that this El Nino, no matter how much rain will come, will not end the drought in California. I've heard people saying we need 4 El Ninos like that to end the drought. So, yeah, we're in a big trouble. And so it probably will continue to dry. This part of the world so the predictions are that the regions that are wet will get wetter and the regions that are dry will get drier. So we have to figure out how to navigate this and how to better manage the water supply that we have and better store whatever precipitation comes, because currently our system is not designed in such a way to capture all the water that comes in terms of rain. So for us, the challenge will be the continuous droughts and continuing drying out. And so there are missions. I would like to talk briefly about what missions observe these different phenomena, but maybe did I want to say something more about? The other missing piece is as related to dryness. Where is the water vapor going? So recent data suggests how the flow of water vapor is changing, and we need more observations in this direction. So the observations that are being taken today include observation of the ocean surface height. so-called topography, ocean surface topography, which is the way to actually monitor the El Nino, the state of the El Nino and La Nina, because warmer waters expand, so the height is higher. So we can see actually the sea surface is not flat. I mean, the difference is small, but we can see when it gets higher in one end of the ocean and lower in the other. So that's one mission. A continuation of missions of this type that started, I think, with TOPEX, Poseidon, and now Jason 1, 2, and 3 is coming up, and they've been monitoring. This is altimeter missions that measure the height of the ocean surface. Another set of missions that is related is the ocean surface wind observations. They're done by scatterometers, and actually JPL was one of the first scatterometers years ago. It was launched by JPL, and then most recently we had a mission called QuickScat, which lived for 10 years and produced climatology, like now long-term climatology of the ocean surface winds. So by looking at the winds, we can see both the manifestation of El Nino. As I said, it's a reversal of the wind of a type. So we can see the manifestation of El Nino, but we can also see the evaporation from the ocean, because this is the direct contact between the atmosphere and the ocean, is on the ocean surface, and the winds are very important contributors. We can see how they reflect the global circulation of the ocean. Actually, I'm looking into that. Not the ocean, but the atmosphere as well. And we can see a reflection of the large-scale atmospheric circulation. But these winds are important for driving the ocean currents, so that's the other relationship. And then we are monitoring the precipitation. There are now it's a constellation of satellites which are called the Global Precipitation Measuring Mission, and it's international. Oh, I forgot to mention that scatterometers is now an international set of instruments too, including Europeans and actually Indian as well. A satellite which was managed by ISRO, Indian Space Research Organization, flew for 3 years, and right now we expect another one to be launched. And there is also another JPL instrument flying now on the International Space Station called RapidScale, which is also part of the ocean surface measuring missions. And then to the precipitation, it's an international effort. So it's called a constellation of satellites that look at many atmospheric parameters, but the rain is one of the important ones. And then there is this other mission called GRACE, which is very interesting too. It measures, it basically measures where the mass of the water goes, how it moves from the oceans to the land. It measures the gravity of the surface underneath, but that gravity is a reflection of changes of mass, and these changes of mass are really the water which is going here and leaving the other places, or in reverse. For example, right now in California, as I said, it's a big drought, and if you see the maps made by this mission, you see how dry it is. So, it's a big body of drought.
Yeah.
And of course, there are other missions that measure the atmospheric composition and the ocean, the carbon dioxide and monoxide, which are the contributing factors to the global warming. And
excellent. I'm sure that there's a lot of areas, and I'm very happy that you mentioned quite a bit. But obviously, these are not covered in the mainstream media, so common people don't know much about these areas. There's a lot of research is happening, but if somebody is interested, they want to, subscribe to some kind of a news which focuses on global warming and climate change. Are there any sites or anywhere they can subscribe so that they keep getting such news?
Oh, that's an interesting question. I'm not prepared to tell you such sites, but there are. I think it's mostly it comes in the news when something of importance happens, and then you can continue following. What I would suggest is for your listeners, if you type in Google, if you Google climate change or El Nino, there are so many articles that will come up, and there are places that you could monitor the evolution of this current El Nino or just read on El Nino as a phenomenon. Actually, it's part of the Wikipedia. If you type El Nino and Wikipedia will explain what the event is. But then there are many sites, and NOAA is probably the most important site to look at. And there is, I can tell at least one which talks about El Nino. It's a long name though, but it's www.noaa.news, one word, and NOAA is NOAA, so NOAA news, one word, .noaa.gov, and then /stories 2015. And I guess if you start from there, you can read, people can read on many different subjects.
I see. So basically, NOAA.gov is a good site, and they can get more information from there, right?
Right. Yeah. For example, there is El Nino forecast site, which is a different website, but you can go from the NOAA website, and I can give you that one. But again, it's a long name.
Right. Before I wrap up, I just heard something interesting. You said about what Indian the ISRO organization is working on and stuff like that. So, is there do the scientist communities work closely with each other across different countries, or is it they work on a silo model? Whatever they do, they don't share. Is there an anonymity and stuff like that?
No. Actually, yeah, you're right. There is a great cooperation among scientists from many different nations. I would say all the nations that have satellites in space, there is a great collaboration, and it's getting better and better. So, scientists do work together in exchanging ideas and in planning and exchanging data to study the phenomena. Yeah.
And I guess there is also some scientists also come from ISRO and visit JPL, right, in California here?
That's correct, yes. We actually had visitors last year.
Excellent. That is great to know. You shared a lot of information. It actually takes me some time to, grasp everything, but it's very useful, and I'm glad you spent this time with us.
Thank you so much. Thank you for the invitation. It was great to talk to you and to your listeners, and I hope there was some useful information for everybody.
Absolutely. Thank you, Svetla.
Thank you. All the best.
Thank you. Bye.
Friends, if you liked today's show, please go to youtube.com/NRI Samay and click on the subscribe button. You will get notified every time we publish a new show. And you can also like us on our social media sites like Facebook, Twitter, and Google+.